Thank you very much, everyone, for joining today. So, my name is Srini Matam, president of Toyota Motor Manufacturing, West Virginia. So, a little bit about my background. First of all, thank you, Kim, and the whole team for inviting me to this presentation. My name is Srini Matam, originally from India. I've been living here for 30 years. My education, I have a bachelor's in mechanical engineering and master's in production engineering. I've been an engineer for a while, and then I switched fields to go to information systems in 1990, then came back to manufacturing. Now I'm the president since 2019. You can see my hobbies there. I read a lot of books and watch cricket, other stuff. So we're located here in a small town, Buffalo, north of I-64. Here are all the products we make here in the plant. So on the left, you can see the engines. On the right is the transmissions. We make three different types of engines, and they go into Corollas, Lexus RX, Highlander, RAV4s. Probably you're familiar with some of those vehicles. And then our transmissions, we have two different plants here. So they go into Camrys, RAV4s, Highlanders, Lexus ES, Avalon, and Sienna. So pretty much every different vehicle that we make in North America. So first, I'd like to first give a explanation of what our goals are for the environmental challenge of 2050. We have 6 challenges. The first one is we want to be new vehicle zero CO2 emissions for new vehicles. And the second one is once the vehicle is in the field, for the life cycle of the vehicle, we want to have a zero CO2 emissions. Also within the plant that's making the vehicles, we want to be CO2 neutral. And then challenge 4 is protect our water resources. Challenge 5 is overall ensure all Toyota facilities and processes support a recycling-based society. And challenge 6 is everything what we operate and make, we want to live in harmony with the nature. That's our goal. With that said, I'm going to touch on 2 challenges and then lead into the STEM discussion. First challenge is vehicle CO2 emissions. Obviously, there's a lot of discussion about electric vehicles. If you look at it today, on the left side, we make a lot of engines which use gasoline. It's called internal combustion engine. We're into hybrid vehicles already, if you look at 2020 timeline, and we're stepping towards 2050. That's how we want to get zero CO2 emissions. The second challenge I want to share with you is the plant side, zero CO2 emissions. We invested $4.9 million, the largest solar array. You can see on the picture on the right that generates 2.6 megawatts of total electricity that we use within the plant. It doesn't support all of it, but it supports 25% of our electricity that we use. So now back to all of that effort that we're putting in. It has a big connection to the STEM careers and how we use these technologies and how our maintenance and engineering folks support these systems. First of all, from a STEM career standpoint, we have the accounting and finance related to manufacturing, information systems, skilled maintenance, and then you have several engineering disciplines. You can see I'm not going to read all of it because of the time. Today, what I'm going to do is I'm going to touch on the skilled maintenance, leading to what Hannah talked about earlier, the advanced manufacturing technician. Hannah, by the way, I was one of the board chairs of Bridge Valley until summer this year, and then I retired, and then I have a new member supporting Bridge Valley, a great institution, and we partner with Bridge Valley to promote the advanced manufacturing technician. Let me explain a little bit more detail. So mainly this leads to a skilled maintenance that work on the machines to repair them, maintain them, and make sure that we're producing our engines and transmissions. That's the main skill set. And if you look at it from the bottom left, That's our K through 5. At that point, I think what may need to happen is basically you want to expose your students to manufacturing by encouraging them to be in STEM. That's our gateway to technology. And then as they get into middle school, then you're thinking about the critical thinking, the communication skills, more exposure to the manufacturing. Definitely recommend enrollment in Project Lead the Way. And then as they grow again in high school, that's when they start getting introduced to the advanced manufacturing technician, and Toyota and the FAME, the manufacturing institution basically, and apply for the AMT program. And there are some requirements. I think Bridge Valley is the one that administers all of the AMT programs. So Hannah already explained about the AMT a little bit. And then you go into the assistant degrees here through Bridge Valley, especially for the skilled maintenance. It's called Advanced Manufacturing Technician. And I'm going to go more into how that program works in a little bit. And then you do the internship. It's a paid internship, and become a potential team member here in the plant. And then if you look at it, how does the AMT program work, which is the Advanced Manufacturing Technician? Students basically work 2 full days of classwork at Bridge Valley. And then they work here on the plant 3 full 8-hour days. And then the instructional program continues through the summer. There is no summer break. And then the weekly schedule, this is how it's going to look. For example, on Monday and Wednesday, on Wednesday and Friday, they come to Toyota to be on the production lines to support our maintenance folks. And then on Tuesdays and Thursdays, they go to school. And here is the general idea about the degree program. You have the general education with the math, writing, science, social science, and public speaking. It's a 5-semester course. And then you get into the manufacturing floor experience with the production and maintenance and so on and so forth. And we also teach the safety culture, the workplace organization, lean manufacturing, problem solving, very important, and then maintenance reliability. So the program's results are the conclusion of the 5-semester program. So the students are going to get an associate degree in applied science, and they'll have 65 college credit hours and 14 months of real world experience because they've been working 3 times a week in the plant. And many other experiences highly sought after by employers. For example, problem solving is one of the key things, critical thinking, and safety. And so far, we're having 100% job placement of the 2-year graduates that graduate out of AMT. And also AMT pass rate on the Toyota's tough technical test is 100%. And also on the 100% completion of the lean manufacturing core program, and then professional behaviors as well. So a lot of good programs. So what I'm going to introduce to you now is within our plant, what type of technologies do we use that either an AMT program or a general STEM education through engineering, the possibilities of what jobs could be available in the plant. For example, we have robots doing work in the plant. And the one on the left is a heavy load robot that lifts a lot of weight. That way the humans don't have to do it, but there's a lot of need for programming these robots. On the right, you see a collaborative robot, which is a human-friendly robot, 2 different types of it. For this, you see math is very important, and mechanical, electrical, computer science, and skill maintenance knowledge is very important. And I'm going to demonstrate one of the small robots here. This is a video I'm going to play. What this is doing is it's wiping a pot to be clean. That way humans don't have to touch the pot and get cuts on their fingers or anything. And this helps to glue this aluminum part to another part of the assembly. And that's how this robot works. And there's a lot of need for programming these robots, and these are taught during the AMT associate degree program. And here is another example of programming a automated guiding vehicle. Basically, it picks up a finished product, and once it's loaded, it automatically takes it to the next line. So there's no human involved. So again, from a STEM education, it's very important for the manufacturing side to continue to support the technologies that help manufacturing products. This is one of the examples. I don't mean to say you need to know what this is. It's a drawing, and it's an engineering drawing of the part I just showed you where the robot was wiping. And there are a lot of intricate details if you can see it. And if you know the math, and you can learn the drawing through engineering programs, especially mechanical engineering programs, students will be very interested to get involved in all of the details of this. So the other thing I wanted to explain to you, the tolerances, some of the machining tolerances we use on the parts, how much of machining works goes into these aluminum parts. I want to explain the tolerances we use. For example, we use at a micron level. Sometimes it's not millimeters or centimeters. A micron is a 1,000th of a millimeter. You're taking material off of these aluminum pieces during machining, 1,000th of a millimeter. What does that equate to? For example, if you see a dark circle, that is the size of a human hair. And then the red dot in the middle is a red blood cell. That's 8 microns. But the black dot within the red dot is 2 microns. So that is the level of machining and cutting of materials we do to make a high quality product. And this requires, and that's what it's showing here in animation, this requires a lot of CNC programming skills, which comes through, again, the STEM education. And you can see on the right-hand side, that is the CNC programming we use here. And then you see a tool and a piece that it's cutting holes into. And you can see another image of it. The programming is on the left side of it, that you run that program wherein the cutting tool goes in and cuts the holes within the transaxle case, which is aluminum case, basically. And you can see another image of this. So the STEM skills needed here for CNC is, again, math, because you will learn the programming skills, the logic, the problem solving, and so on and so forth. And it deals with mechanical and skilled maintenance. And then 3D printing is also big here at Toyota, and generally everywhere. You can see there are different parts that we hold in these nylon holders. These nylon holders are made with 3D printing. And again, there's a lot of programming that you can learn, the drawing you can make to the tolerances. And that way we can print inside. And this is getting really big. The 3D printing is going big in the industry. And finally, how can we support at Toyota, right? We can do a plant tours to teachers and students, and you can reach out to us. And also STEM day for students, and we can shadow with engineers, maintenance, quality engineering, and others. And we can share the job responsibilities of engineers to get that STEM education introduction. That way the students can pick and choose how they want to grow in their own careers, right? And show automation, we can show the robots that I showed in the video, the AGVs, and show our training areas, the fundamentals of engine manufacturing, transmission, and general problem solving. Of course, we can show the CAD, the computer-aided design development and 3D printing. And that's all that goes on here. We're excited to share anything with all the teachers and students. Let us know if you need any help. That's all from me, Kim. Thank you.
All right, thank you so much again. And I mean, you brought the robot to our last event that we had you at in West Virginia, and honestly, like those diagrams are incredible. So I really enjoyed that part. Thank you so much for presenting.